Welcome to The Explainer. Today, we're diving into something that is literally going to test the absolute limits of human comprehension. I mean, when you look up at the night sky, it feels completely infinite, right? But what if I told you that our view of the cosmos actually has a strict, definitive boundary? We're going to explore a seriously mind-bending premise today, grounded in recent cosmic visualizations and documented astrophysics. We are heading straight to the edge of the universe. Well, actually, scratch that. The edge of our universe. Okay, let's dive into this. This spatial journey into the unknown is easily one of the most fascinating topics in all of science. Picture this. You're standing in the middle of a vast pitch-black forest with just a flashlight. Your beam only reaches so far before the darkness just completely swallows it up. Space works in a remarkably similar way, but on a scale that totally defies human imagination. We are going to trace the path of light, push way past the galaxies, and confront the ultimate question: what exactly lies beyond the end of everything we can see? But to even begin to answer that, we first have to wrap our heads around the sheer, terrifying scale of the boundary itself. 46.5 billion. I really want that number to just sink in for a second. This is the distance, in light years, to the very edge of our vision in every single direction. To put that into perspective, just one single light year is roughly 6 trillion miles. Now take that unfathomable distance and multiply it by 46.5 billion. It's wild! Whether you look north, south, east, west, straight up, or straight down, this number represents the absolute hard stop to human observation. We are literally sitting in the dead center of a massive cosmic sphere with a radius of 46.5 billion light years. But throwing around a massive scale drop like that often leads to a major misunderstanding about what that boundary actually is. So the crucial point here is that this boundary is not a physical wall. You wouldn't just bump into a giant brick barrier at the end of the cosmos. It's not the end of everything. What we're actually talking about is the observable universe. That's the specific region of space containing everything we can ever possibly see, bounded by that edge 46.5 billion light years away. It is absolutely crucial to separate the concept of the end of the universe from the end of our vision. The limit we're dealing with is strictly an observational one, dictated entirely by the speed of light and the age of the universe itself. We are basically trapped in a giant cosmic bubble of visibility. And this brings us to a really vital distinction. There is a massive fundamental difference between our personal, observable reality and the totality of what actually exists out there. On one side, we have the observable universe, everything we can ever see: the galaxies, the stars, the cosmic structures whose light has actually had enough time to travel through space and reach our telescopes. But on the other side, we have what actually exists, the true universe in its entirety. The universe doesn't just suddenly stop existing simply because our line of sight runs out. The reality of what's out there extends far, far beyond our 46.5 billion light-year bubble. So you're probably wondering, why does this bubble even exist in the first place? Part 1. The physics of the edge. Why our vision is limited. To understand why our vision is so strictly contained, let's move along and see how this builds across 3 scientifically documented mechanics. We aren't dealing with guesswork here. This is rooted in hard, observable phenomena. First, we have the expansion of space. Second, the cosmic microwave background. And third, the event horizon. These aren't just abstract wild theories. They're the fundamental rules of the road for the cosmos. And together, they literally construct the cage of our observable reality. Let's break down that first mechanic. The expansion of space is a well-documented cosmic phenomenon where the fabric of the universe itself is stretching. Think of it like this. Imagine drawing 2 dots on a completely deflated balloon and then blowing it up. The dots themselves aren't moving across the rubber, but the space between them is expanding, right? The universe is doing exactly this, stretching distances out on an incomprehensible scale. The crucial takeaway is that because the very fabric of space is expanding, objects that are incredibly far away from us are being pushed even further away at staggering speeds. This physical stretching of space dictates the boundaries of our universe, because eventually, the space between us and those distant objects is expanding faster than the light from those objects can even travel toward us. And this brilliantly illustrates the next piece of our puzzle: the cosmic microwave background. This is the earliest observable radiation in existence. It's essentially the fading afterglow of the universe's fiery beginnings. You see, because light takes time to travel, when we look out into deep, deep space, we're actually looking back in time. When we look all the way out to the very edge of the observable universe, we aren't seeing stars or galaxies anymore. Instead, we're seeing this background echo of ancient radiation. It forms a hard, documented boundary of the universe's past. We literally cannot see past it, because before this radiation was emitted, the entire universe was a dense, glowing, opaque fog where light couldn't travel at all. It is the absolute limit of what we can perceive. Finally, we have the cosmic event horizon. Now, you usually hear this term tossed around with black holes, right? But the observable universe actually has one too. By definition, it's a boundary beyond which events can never affect an observer. Because space is expanding, and because that expansion is actually accelerating, there are regions of space moving away from us so incredibly fast that light emitted from them today will literally never, ever reach us. No way, not ever. The event horizon creates a strict physical limit on the information that will ever be able to cross the cosmos to reach our telescopes. Whatever happens beyond that horizon is permanently cut off from our reality. Part 2. Over the edge, entering the unknown. The expansion, the background radiation, the event horizon, they all lock us in. Now, what's really interesting about this dividing line is that everything we just talked about, what happens within that 46.5 billion light-year radius, is well-documented science. We've got the data, we have the radiation measurements, we know the physical laws. But the second we step over that jagged mathematical edge, we leave documented physics completely behind and enter the realm of pure speculation. The true universe doesn't care at all about our observational limits. It just keeps going. But what does it actually look like out there? Is it just more of the same? More galaxies, more stars, more massive empty voids? Or do the laws of physics themselves begin to warp and change into something unrecognizable? Because we can never receive light or information from beyond the event horizon, our science stops cold, and our imagination has to take over. Which leaves us with the ultimate unknown. Does the universe have a true physical edge somewhere way out there in the dark? Or does it simply continue infinitely forever? If it does have an edge, what in the world is outside of it? And if it's truly infinite, how can the human brain even begin to process something that just has no end? Our 46.5 billion light-year bubble is really just a tiny microscopic drop in an ocean we can never fully chart. The boundary of our vision isn't the end of the universe. It's simply the beginning of the great unknown. So keep looking up and never stop wondering about what lies beyond the dark.